Hello, this is Ms. DB. In this video, we are going to learn about exponential growth and decay. So our objective is to solve problems involving exponential growth and decay. So exponential growth occurs when a quantity, that's a typo, increases by the same rate r in each period t. So this is an example of a geometric sequence or an exponential function. So when this happens, the value of the quantity at any given time can be calculated as a function of the rate and the original amount. So if it's exponential decay, we use this special formula, and we actually had that formula given to us in the 11.2 assignment as an example of exponential as an exponential function. So when it's exponential growth, you take the rate as a decimal. Have to change it to a decimal first, add 1. Then you take that to the t power with your calculator, and t is time. They'll give you that in the problem. And then you multiply that by your original amount. And if you do that, you will be able to find the final amount after exponential growth has occurred for a given period of time. Here's an example, and your problems are going to look just like this. So here we have the original value of a painting is $9,000. In the formula, that is our original amount A. And the value increases by 7% each year. 7% as a decimal is 0.07, and that's going to be our R, our rate. Write an exponential growth function to model this situation. So we write it using t as a variable. And then we solve that equation using 15 equals t. So first we write the function, replacing everything except for t and except for what we're looking for, and then we'll solve it replacing t with 15. All right, so we know that A is 9,000. We know that 0.07 is R, so we put that in there. That's step 1. That's part of the answer to this question. Then for the second part, you can simplify that a little bit, and now we'll replace 15 for t. So we write the same thing over again, and then we use our calculator to find, there's no reason to go back to writing it that way. I don't know why they did that. You would just leave this as 1.07. And then take that to the 15th power. Now remember that you have to do that before you multiply by 9,000. And when you do that, you leave the 1.07 to the 15th. Leave that on your calculator, hit equal, and then multiply that by 9,000, and you get your answer. So on your worksheet, you have two problems that are exactly like this. First thing to do is to go ahead and identify what is our original amount, what is the rate. And then in step B, you're going to write the function. It'll have t in it, it'll have y, and then for C, you're going to replace t with 8. Let's do, we'll at least start number 2. So the population of a town is 4,200 and increasing at a rate of 3% per year. A is our original amount of 4,200. The rate, we have to change 3% to a decimal. So 3%, move the decimal, which is at the back, 2 places, and it's 0.03, not 0.3. Then we replace, let's see, A is 4,200, parentheses 1 plus R is 1 plus 0.03 to the t power. And we can simplify that a little bit by adding the 1 plus 0.03. And then in C, you will take and replace t with 7. And then you get your calculator out, and 1.03 to the 7th power is a really long number. 1.229873865 on my calculator. You don't have to write all that down, because now you leave that on your calculator, and now you multiply that by your original amount. So this is exponential growth, so we would expect that this number would be bigger than our original, and it is. So I got that y, the population of this town after 7 years would be 5,165.47. Next thing we're going to do is a special kind of exponential growth called compound interest. So if you have a savings account or take out a loan, you will learn about interest. Compound interest is the interest earned or paid on both the principal and previously earned interest. So for compound interest, if you have $5,000 in a savings account and you're earning 1% interest, then when you get a little bit more money because the interest is added to it, then your compound interest is based on that. So it grows faster than just simple interest. There's a special formula for compound interest, and it involves some more parts. It involves this n. N is the number of times interest is compounded per year. Sometimes it's compounded 4 times a year, quarterly. Sometimes it's monthly. Sometimes it's weekly. So you have to use the n as part of your equation. Otherwise, it looks a lot like the one we just used, the exponential growth. And we still have rate is the same thing as a decimal. Instead of using A for the original amount, they use capital P for the principal, which means the original amount anyway. T is still time. And instead of Y equals, they call this A equals. It's just a special formula used by the finance industry. So annually is once a year, quarterly is 4 times a year, of course monthly is 12 times a year. All right, so let's look at this one. We have the 12,000 invested, so that's your original amount. That will be P in our formula. Here's the rate, so the R is going to be 0.02. It's compounded quarterly. Compounded quarterly means 4 times a year. And then this will be our second part. First, we're going to write the equation, and then when we're done, T equals 3 is what we'll substitute in, just like in the last one. All right, so we need the formula. That should be on your paper. It is on your paper, but if it's not for some reason, you would write that down. And then we'll replace all the parts that we know. We know P is 12,000, we know 0.02 is R, and we know 4 is N. This can be simplified. It's a little bit trickier to simplify than the last ones. We don't just add the 1 plus 0.02. You first need to divide 0.02 divided by 4, and that is 0.0005, and then we would add 1 to that. So we have 1.00, I think I said too many zeros, 1.005, and then that'll be raised to the 4 times t power, and then the 1200 is the principal amount. Okay, then our next step is to go ahead, now that we have our equation all set up, is to plug in t for 3. And then you multiply the 4 times 3 and get 12. And then remember that this next part on your calculator needs to be done. 1.005 to the 12th power. And if you did that, you should get 1.061677812. And then you multiply that times 1200. And if you had just rounded that to 1, then you'd have 1 times 1200, or 1200, you would have lost $74. So don't round this, just leave it on your calculator and then multiply by the principal to find your total. So you have 2 problems to do on your worksheet, and they're just like the one we just did. Let's look at, let's do 4. So in 4, we have 4,200 is invested at a rate of 2.8% compounded quarterly. In this one, n is 1. In this one, n is 4. That's already given to you. P will be the 4,200. Our rate is 0.028. So this time the rate is 2.8. So you move it 2 places to get 0.028. And now we write our equation, our formula. So P is the 4,200 times 1 plus R, 0.028, divided by n, which is 4, to the n, 4, we know n is 4, t. Now we simplify this. We simplify what's in the parentheses. Okay, so 0.028 divided by 4 is 0.007. So we have to take 1 plus 0.007, and then that will be to the 4t. So this is the answer for B. And then in 6, we use this formula, except that we plug in that t is equal to 6. So 4 times 6 is 24. And then you calculate this on your calculator and you will find your answer. Now this is compound interest, so you would expect it to rise. It'll be great. Your answer will be greater than 4,200, but it's not going to be like 42,000. It's not going to be super big. It's interest at a bank. They're not going to like double your money here. So you would expect your answer to be, you know, between 4,200, of course, and maybe like 4,400, 4,300. So if you get some giant number, then you'll know you made a mistake. Or if you get a number less than 4,200, you're not going to lose money when you're investing. Okay, exponential decay, that is when you will lose. It will be less than your original. So if a quantity decreases by the same rate in each time period t, then this is an example of exponential decay. The formula for this is exactly the same as for exponential growth, with a minus sign instead of a plus. So everything else is the same, but we subtract 1 minus the rate, and then we continue. All right, so here's an example of a population of a town decreasing at a rate of 3% per year. In 2000, there was 1,700 people. So this is our original amount, and our rate is going to be 0.03. And we are going to write an exponential model for this and then find the population in 2012. So for t, we're starting with 2000, the year 2000, and we're going to 2012. So our t, our time, when we get to that part, will be 12, because that's in 12 years later. So we start by plugging in 1,700 for A and 0.03 for R, and then we simplify. Now when you simplify, this is minus, don't forget to subtract, and that's 0.97. So that is our answer for the part that asks you to find the formula of the model. Now we plug in that t equals 12. And you use your calculator and you take 0.97 to the 12th power and take that answer and multiply by 1,700. And again, this is a town that's decreasing in population, so it should be less, and that is what we found. If we ended up with a number greater than 1,700, we had made a mistake. You have 2 problems to do on your assignment like this. I'm going to let you solve each of them on your own. Remember, you're subtracting. The rate, if it's a 2-digit rate, the rate will not be 0.0, it'll just be 0.16 or 0.12. And then the A is the original amount, so in number 6, the original amount is 10, and it's decreasing at a rate of 16% per hour, and you'll continue solving these questions. Okay, the last thing that we're going to talk about for an application is exponential decay. Is called half-life. This often is an example that we take from science. So the half-life of a substance is the time it takes for 1/2 of the substance to decay into another substance. This happens with elements, like there's radioactive decay, or in the bloodstream, when you take medicine, it will have a half-life. So it's the special thing where we use this. Whoops. Did that one. We always use 0.5 because that's half. So we want to know 0.5 to the t, and then we multiply that by p, the original amount. So they have to give you the half-life. Now the only confusing part of this is a lot of time the elements that we are having a half-life of have numbers in them. This is just a name. We don't use the 218 in any way. This is just a special name, acetine 218. They just often have numbers as part of the way they've been named. So it has a half-life of 2 seconds. We want to know, if we start with 500 grams, how much will there be after 10 seconds? So the half-life, this is the hard part. we have to find the number of half-lives in the given time period. There's this step here, which is different than all of the other problems we've done. So we take the time period, we have to take the time period they give us, and we divide by the half-life that they also gave us. So we take the 10, the time period they gave us, and we divide by its half-life. So there are 5 half-lives in this time period. That's what we use for t. So 10 seconds divided by 2 seconds is 5. And now we're ready for the formula. So there's this extra step in finding half-life that we don't have in the other examples we've looked at. Then the rest is using your calculator to take 0.5 to the 5th power and then multiply that answer by 500. So this answer should be less than what we started with. They started with 500 grams. After 10 seconds, there's only this much left, because it only takes 2 seconds for it to be half of that. Okay, let's look at these. Here we have an element named bismuth 214. Again, this is just the name of the thing. The 214 doesn't have anything to do with it. Has a half-life of 20 minutes. Find the amount that remains if you start with 30 grams after 1 hour, which is 60 minutes. So again, in A, we have to find the number of half-lives first. So in 60 minutes, if it has a half-life of 20 minutes, that has 3 half-lives. And then all you have to do is put in T is 3 and P, where's our P, is 30. So you put P is 30 and T is 3, and then you'll be able to answer the question. And for this last question, it's already set up. It tells you how to find the number of half-lives. Plug in that P is, 44, and you'll find your T here, and you'll be able to solve to answer the question. There's a few questions at the end for you also to go through, so don't forget about those. If you have any problems on this assignment, please let me know. Have a great day.